quotient rule says that if you want to take the derivative with respect to x of the quotient of two functions, and this bottom function is not equal to 0 at the point of interest, then what you can do is take the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. You should memorize this rule because it comes in handy sometimes. So you'll see later on that there are tricks to avoid memorizing this rule, but I would encourage you to do it. Now, some people have a little rhyme that they use, and I'm not particularly nuts about it, but they say it is the low times the derivative of the high minus high times the derivative of low, cross the line and square below. So if you can memorize that rhyme, then that would work too. So notice that if you do it, a lot of times people get it backwards. If you think it's the high times the derivative of the low minus the low times the derivative of the high, cross the line and square what? It doesn't rhyme. So low d high minus high d low, cross the line and square below is that rhyme. Just make sure that it really truly does rhyme so that you get the correct answer. Let's look at an example of what we're talking about. Suppose we have the quotient of two polynomials, x squared minus 1 on top and x cubed plus x plus 1 down below. According to this quotient rule, you take the derivative of the top, which the derivative of this top, using the difference rule, is just 2x, right? Because the derivative of this constant is 0. Derivative of the top times the bottom minus the top. And the top is x squared minus 1 times the derivative of the bottom, which is 3x squared plus 1 plus 0, all over the bottom squared. So x cubed plus x plus 1 squared. Okay, now the calculus is done, but when you have a fraction, you usually try to put that fraction in lowest terms. To get this in lowest terms, what I'm going to need to do is factor. But before I can factor, I'm going to need to expand this. So I'm going to multiply it all out, collect like terms, and then see if I can factor. So if I multiply this out, I have 2x to the fourth plus 2x squared plus 2x, and then minus, if I multiply this out, x squared times 3x squared would be 3x to the fourth, and plus x squared minus 3x squared, and then minus 1, all over x cubed plus x plus 1 squared. So if I distribute this negative through, then I can collect my like terms. I'm going to have a negative 3x to the fourth, and x squared minus 3x squared would be negative 2x squared, but then this other negative makes it positive 2x squared, and then finally minus minus 1 is plus 1 over x cubed plus x plus 1 squared. Now I can start combining like terms. My x to the fourth terms combine to give me negative x to the fourth. My x squared terms give me 4, so I have plus 4 x squared. And then I have this single linear term, so plus 2x plus 1 all over x squared plus x plus 1 squared. Now it doesn't look like this is going to factor, so I think we're done at this point. We can't factor this, so there's not going to be any common factors that are going to reduce. So now we've got it as a fraction in lowest terms. We'll go ahead and stop. We found the derivative by using the quotient rule. Now here's a problem involving the quotient rule that you can try. So you give it a shot, and then we'll check your work in the next video.